This isn't a drone. This is a flying superstructure.
Meet the Skylifter, built to move what no aircraft ever could. Every giant aircraft begins with metal shaped by fire. Lightweight, only in appearance. This floor is built for giants. Inside this chamber, raw materials transform into aerospace-grade armor.
These pieces become the internal bones that distribute aerodynamic forces throughout the Skylifter.
Precision here determines performance up there. The coverage on the underside looks consistent.
Confirmed. We are hitting the target thickness perfectly.
Before assembly begins, every piece must know where it belongs.
Check the trailing edge tolerance right here. Yep.
Looks stable within the parameters. Keep scanning.
Electrical arteries give the Skylifter its nervous system. A single seam decides the strength of the entire frame.
Acoustic dampening reduces vibration and protects internal avionics from harmonic stress.
Before this aircraft flies, it must first learn to see. Wings this large begin as threads, woven with aerospace precision.
This compaction step ensures the wing panels cure without voids, giving them the stiffness needed to handle
Inside this chamber, the wing becomes stronger than steel, yet lighter than aluminum.
The spar is the spine of every great wing. Its strength decides how much the aircraft can carry.
These flaps are what allow a giant to rise gracefully.
Make sure the orange harness is seated correctly before the clamp engages.
Got it. Fuel line is clear.
A wing isn't finished until it proves it can handle its own size. Every engine pod begins as a shell, but soon becomes the heartbeat of flight.
The temperature on phase 3 is rising slightly.
It's within tolerance, but let's increase the coolant flow.
Balance isn't optional. It's the difference between smooth lift and catastrophic shake.
Flow rates look stable across all regulators.
Confirmed. Thermal load capacity is optimal.
These blades don't just push air. They move the future of heavy transport. Precision electronics control every watt flowing into these engines.
Here, the engines prove whether they can lift the impossible.
This floor must carry what no other aircraft can.
Automation here means speed, safety, and 0 wasted minutes.
Bring it left. Hold it there.
Okay, locking it now.
Confirmed.
Motorized rollers accelerate loading, reducing turnaround time and minimizing labor.
In this bay, nothing moves without being seen.
To navigate the skies alone, the aircraft needs eyes sharper than any human.
The reflection data looks nominal at this frequency.
Confirmed. Cross-reference with the atmospheric model.
Data moves here at the speed of light, literally.
When every mission matters, avionics must never slip, never fail.
Only under maximum pressure do we know if the system is truly airworthy. When your aircraft weighs more than a freight train, the landing gear becomes a structural miracle. These actuators allow the gear to extend and retract under both extreme weight and turbulent conditions. A single landing on rough terrain can generate forces that would crush ordinary aircraft.
These extra-wide tires distribute weight across large surfaces to prevent runway damage.
It worked perfectly. Look at that absorption.
The data confirms it. We are cleared for the shorter runways. Stability is everything. This aircraft carries the world's heaviest payloads.
The gear is more than hardware. It's the foundation that makes flight possible. Before the engines roar, the aircraft's nervous system must awaken. These tanks store aviation-grade synthetic fuel designed for ultra-long-range, heavy-lift missions. A machine this size doesn't just fly. It generates heat like a small power plant. Power in an aircraft like this is not just delivered. It's orchestrated. Electronics fail when heat wins, and this system refuses to let that happen.
Balance is everything. Too hot or too cold, and thousands of components fall out of sync.
A smooth exterior isn't cosmetic. It's the first line of aerodynamic efficiency.
These stabilizers provide yaw control and stability, compensating for the Skylifter's immense cargo weights and shifting center of mass.
Control surfaces this large transform the airframe into a balanced giant.
When a machine this large rolls, it must do so with grace, not force.
Look at the waveform right there.
It's holding steady below the threshold. The seal is good.
The gateway to the Skylifter's strength must be as strong as what it carries.
The air is unforgiving, so the Skylifter must be ready for every gust.
This intense trial pushes the airframe to its limits, ensuring aerodynamic stability before engine activation.
If the brain doesn't understand the body, no aircraft takes flight. A machine this large must be seen before it's ever heard.
Initiating stabilizer pitch adjustment now.
Confirmed. We have a hotspot forming on hinge Delta 9.
Before full power comes trust. Trust in every drop that moves this giant forward. This is the moment the beast takes its first breath.